In section 1.4, we'll be talking about solving limits algebraically. So far, we've talked about solving limits graphically and numerically, and those are both great ways to find limits, but with some functions that are more complex, we want to be able to solve them algebraically. Also, sometimes we might not be able to figure out the graph very easily by hand, or we may not have a calculator. So there are a few different techniques you can use to find a limit algebraically. The first one you always want to check is to see if you can plug in a. So plug in the x value that you're trying to find the limit at. If you get a numeric value, that's your answer. The other thing we're going to talk about today is manipulating algebraically. There are a few other techniques. So for example, sometimes that limit might be infinite or indeterminate, and we will talk about those later. So let's try out the first step. And so this is, you always want to try this out first. So I'm going to plug in a to f of x. So I'm looking at this x value here, negative 2. I'm going to evaluate that at x squared minus 4x plus 1. So I'm going to plug in negative 2 for all of my x's. And let's simplify that. I would have 4 plus 8 plus 1, that's 13. And that is just my answer. So as long as I get a number there, I'm done. In part B, I can evaluate at negative 1, 2 times negative 1 minus 6 over negative 1 minus 1. And so I get negative 8 over negative 2, which is 4. All right, let's review some trig values. The limit as x approaches pi of 2 cosine x minus x over x plus 2. So I have 2 cosine of pi minus pi over pi plus 2. Let's remember what that is. Cosine of pi is negative 1. So this is actually times 2, negative 2 minus pi over pi plus 2. And so you might recognize those are opposites in the numerator and denominator. And so then when we simplify those, we will just get negative 1. You can also just factor negative 1 out of the numerator and then cancel. So that method worked fine when we plugged in a number and we actually got a real number. But sometimes when you evaluate at a, you'll get 0 over 0. So when you see that you get something like 0 over 0, that doesn't necessarily mean that your limit doesn't exist. What it tells you is that you have more work to do. And so what you want to try to do is manipulate that expression algebraically. And so there are different things you can do. Most often what you're going to do is factor and cancel. The other methods, you might have to do something else first before you can factor and cancel. So let's evaluate the limit of x as x approaches negative 2 of x squared minus 2x minus 8 over x plus 2. So if I evaluated the numerator at negative 2, I would have 4 plus 4 minus 8, which is 0, over negative 2 plus 2, which is also 0. So when I get 0 over 0, I'm going to make these smiley faces because what that means is we have more work to do. And we're always excited to do more calculus. And so our first thing is to look at this and decide, is there anything I can factor? And I can see that I could factor the numerator. Now what's important here is that I have to still write my limit at the front of my expression. And I have to do that until I actually evaluate this at negative 2. So I haven't actually plugged in the negative 2 yet, just still factoring. And my factors are x minus 4 times x plus 2 in the numerator. So what I notice now is that I have an x plus 2 in both the numerator and the denominator, and those will cancel out. So what I'm left with is the limit as x approaches negative 2 of x minus 4. As soon as you factor and cancel, you want to try to plug in again. So I have negative 2 minus 4. That is a real number. It is negative 6. And that is my answer. So again, our process, we try to evaluate it first. If we get 0 over 0, we know we have more work to do. We try to factor and cancel. After we cancel, then we try to evaluate again, and then that will be our final answer. So once again, make sure you are writing those limits in the front of your expression until you actually evaluate at that x value. All right, let's try B. So if I take the limit as x approaches 0 of 5x cubed minus 5x over x squared plus x, if I try to evaluate that at 0 first, I again get 0 over 0, which tells me I have more work to do. So I'm going to factor. So in the numerator, I could factor out a 5x. And the denominator, I could factor out an x. Now you might look at this and say, well, I can factor some more. You can do that. I could try to simplify first. It's up to you. I'm going to go ahead and factor it. I would prefer to see all of my factors. 5x times x plus 1 times x minus 1 all over x times x plus 1. So I see here the factors that cancel are x plus 1 and x. So what I'm left with is the limit as x approaches 0 of 5 times x minus 1. Now I'm going to evaluate that expression at 0. So notice I no longer write limit in front because I'm actually plugging in the 0. And then I get my answer, negative 5. All right, what I want you to do right now is pause the video, see if you can do part C on your own. All right, I hope you were able to try to get this on your own. If I evaluate this at 1, I do get 0 over 0, which tells me there's something else I need to do. So we're going to factor. The numerator factors into x minus 1 times x minus 1. The denominator is x times x squared minus 1, which would factor into x plus 1 times x minus 1. Now I can see what will cancel. Just the x minus 1s. Now I'm rewriting this here. Once you get comfortable, you don't necessarily need to rewrite it after you cancel, but I find it helpful to make sure I'm evaluating correctly. So when I evaluate this at 1, I get 1 minus 1 over 1 times 1 plus 1, which is 0 over 2, which is 0. It's okay if I have a 0 in the numerator, as long as I don't also have it in the denominator. So that's just my answer. All right, so there are some other more complex algebraic expressions that we might want to find the limit of. So like in D, it tells us to find the limit as x approaches negative 1 of square root of x plus 2 minus 1 over x plus 1. Now, there's nothing really here that I can factor or cancel like we did in part 1. And so what you really want to do when you see a radical is you're going to rationalize. You may remember from pre-calculus talking about rationalizing the denominator. In calculus, it's not always going to be the denominator. It might be the numerator. And so what I'm focused on is this part with the radical in the numerator. I'm going to multiply by the conjugate of that. And so what the conjugate is it's the same radical, square root of x plus 2, and the constant term. I'm only changing the symbol in between. So square root of x plus 2 plus 1, and then the denominator, square root of x plus 2 plus 1 as well. Whatever I do to the numerator, I have to do to the denominator. And now I'm going to expand. I actually only want to expand the numerator, so I'm only going to expand either the numerator or denominator wherever the radical was to begin with. In this case, that's the numerator. So square root of x plus 2 times square root of x plus 2 is x plus 2. And then I have square root of x plus 2 times 1, so plus square root of x plus 2. And then minus 1 times square root of x plus 2. And then minus 1. I'm going to leave the denominator in the factored form, x plus 1 times the quantity square root of x plus 2 plus 1. And you'll see why in a minute. So at this point, my goal is to still try to cancel out some factor. So let's see if we can simplify. Square root of x plus 2 minus square root of x plus 2, that cancels. That should always happen in this case, otherwise you might have not written your conjugate correctly. So I have x plus 2 minus 1, that will be x plus 1. And what you may notice is we had an x plus 1 in the denominator as well. And so I can then cancel those factors. So just like before, we had to rewrite it first before we could factor and cancel, but then we cancel. And now we're going to try to evaluate this again at -1. And so I have 1 over square root of -1 plus 2, which is 1, plus 1, which gives me 1/2. For part E, we have a complex fraction here, which means there's a fraction inside of my fraction. You might be tempted to find a common denominator of these two fractions in the numerator and then simplify. However, I find that it's easier to multiply by my least common denominator in both the larger numerator and denominator. So what that means is I'm going to multiply this numerator by both of the denominators here, unless they had a common factor, but usually it's both of the denominators, so 3 times x plus 3. And then I'm also going to multiply x by 3 times x plus 3. So this is going to help me simplify, and I don't have to worry about what level each term is on. It's just going to make things a lot easier for me. You do have to make sure to distribute up here. So 1 over x plus 3 times x plus 3, the x plus 3's would cancel, so I would just have 3 minus 1/3 times 3 times x plus 3, the 3's would cancel, so I have minus the quantity x plus 3, be careful with your signs there. And then my denominator I can just multiply straight through, 3x times x plus 3. Now I can simplify that some more. Limit as x approaches 0, 3 minus x minus 3, distribute that, so I just am left with negative x over 3x times x plus 3. Now I can see what I could cancel. Originally, with that original limit, I couldn't cancel anything out. So again, I'm rewriting it until I can cancel something. So the x and the x cancels. So I'm left with the limit as x approaches 0 of -1 over 3 times x plus 3, which is -1 over 9.